I got cut off again. I'm starting to think that the document camera thinks I talk too much. Maybe that's a good thing. So, what we were saying, the alpha-1 receptors and the beta-1 receptors, when epinephrine binds or norepinephrine binds to either one of them, we're going to stimulate the cell. This could be an alpha-1 receptor with phospholipase C. This could be a beta-1 receptor with CAMP as a second messenger. For the alpha-2 and the beta-2s, these inhibit the cell. So both the 2s, alpha-2, beta-2, are going to activate phosphodiesterase, break down CAMP or CGMP, inhibiting the cell. Now, for acetylcholine, for that neurotransmitter, the type of receptors there are called cholinergic receptors, which we mentioned in a previous video. And there are two main kinds of those. There are nicotinic cholinergic receptors and there are muscarinic cholinergic receptors. Nicotinic cholinergic receptors are pretty simple. They're just chemically gated sodium channels. So just a sodium channel that opens when you bind acetylcholine to it. That's a nicotinic receptor. And these are called nicotinic receptors because you've got the ability to stimulate them with nicotine as well. So tobacco products also stimulate the nicotinic receptors. Muscarinic receptors are G protein coupled. They're not just plain old chemically gated sodium channels. So they're going to have a second messenger. These are pretty easy to remember because M1 and M3 muscarinic cholinergic receptors both activate phospholipase C. So this one, this situation here, we already said it could be an alpha-1 adrenergic. It could also be a muscarinic 1 cholinergic receptor, or it could be a muscarinic 3 cholinergic receptor. So both of those, M1 and M3, are going to stimulate the cell. The M2s are going to trigger phosphodiesterase. So just like this. So this could be an alpha-2, or I'm sorry, not that one. This one could be an alpha-2 causing phosphodiesterase to break down CAMP. It could be a beta-2 adrenergic receptor, or it could be an M2 muscarinic cholinergic receptor. So that's easy to remember too, because there's a pattern here. The 2s all inhibit with phosphodiesterase. Alpha-2 adrenergic, beta-2 adrenergic, and then the M2 cholinergic. All of those inhibit using phosphodiesterase. Easy to remember. Now, muscarinic receptors are called muscarinic because they are also activated by a compound called muscarine. And muscarine is a substance that's found in poisonous mushrooms. So that's why you don't want to just like go walking through the woods and eat a poison or eat a mushroom no matter what it is, unless you are an expert on what kinds of mushrooms are poisonous. Because some of them contain muscarine, and if you don't know, you might get too much muscarine. Now, why that would prove to be poisonous, acetylcholine is something that is used a lot with the autonomic nervous system. So think of your heart rate and your breathing rate. And it's used predominantly by the parasympathetic nervous system to slow both of those things down. So it will cause you to, inhibit your breathing, because when you're, relaxed, you don't have to be breathing as fast. It'll slow down your heart rate. You're relaxed. You don't need your heart rate to be so fast. But if you overstimulate those, you'll be inhibiting all of those processes too much. So you'll be relaxing too much. So that's not good at all. Also, keep in mind when you go into the neurotoxins slide, I want you to read over those. See if you can think of what you know of the neuron activity from graded potentials, from neurotransmitter release, myelination, speeding up action potentials, all of those things. And hopefully that should make the neurotoxins make sense. I want you to really think about the mechanism behind a neurotoxin. So for example, I'll do one. Let's say it blocks voltage-gated sodium channels. If it blocks voltage-gated sodium channels, you can't do any of this. You can't have an action potential, right? So think of it in terms like that, and it'll help you get ready for the test, really understand all of these different processes here. Also, this is foreshadowing for the autonomic nervous system that's coming up in Unit 8. We're going to be revisiting these things because we find these nicotinic receptors in a very specific place in the autonomic nervous system. We also find these muscarinic receptors in other very specific places in the autonomic nervous system. So we'll be looking at those. Also, to a slightly lesser degree, we'll be looking at these adrenergic receptors. So make sure you remember these receptor types even after we take the test, which this is for test number 7. We're almost there. We're almost done. So we're going to see this again when we get to Unit 8. Okay? Okay, that is it for this week. I'll see you next week. Bye-bye.